Alright, hey everybody. So this lab is going to cover the classification and identification of sediments and sedimentary rocks. So this video is a quick summary of the most important observable features for sedimentary rock identification and the main classification steps. So all these topics will be explained in even more detail in the next videos. Sedimentary rocks are composed of sediments that have been compressed, cemented, or otherwise hardened together into a solid rock. Sediments derive from the weathering and disassembling of pre-existing rocks that can be either igneous, metamorphic, or sedimentary. Within a typical sediment, it is possible to find rock fragments, mineral grains, plant parts, animal remnants, and chemical residues. Sedimentary rocks have a more complex structure than igneous rocks, and for this reason they require more steps for the identification of the rock and for producing reliable interpretations. For the first passage to interpreting a sedimentary rock, you need to recognize which group the observed sample belongs to. So this can be done using hydrochloric acid on the sample to see if there's a reaction. The second and third steps are related to the nature of the matrix that links all the grains. Specifically, the second step regards the identification of the matrix texture, while the third is the identification of the matrix composition. The fourth and fifth step are respectively related to texture and composition of the grains. The sixth step is the final identification of the rock, and the seventh and eighth steps are the final considerations that can be done knowing the rock name and its textural and compositional features. As introduced in the previous slide, there are multiple groups of sedimentary rocks. The most represented groups are the siliclastic rocks and the carbonate rocks. The largest part of the carbonate rock group is represented by a family of rocks made by calcite, which are called calcareous rocks. Since calcite produces a visible reaction when it is in contact with hydrochloric acid, it is possible to easily identify a calcareous rock by the presence of this reaction. When the reaction is not present, the observed sample is most likely not belonging to the carbonate rock group. Nevertheless, it is important to remember that there is a less represented group of carbonate rocks called dolostones that are composed of dolomite and do not produce a visible reaction with hydrochloric acid. Another important thing to consider is the possible presence of both silicoclastic and carbonate components in the same rock sample. So the hydrochloric acid test is also useful to identify the calcareous component of the rock that can be represented by the calcareous clasts or by calcite cemented within the matrix.